Hello students, let's see exercise 4.23. For any arbitrary motion in a space, which of the following relations are true? So first is what equation of average velocity, and that is equal to, which is given over here, is a velocity at time t1 plus velocity at time t2, okay, divided by what we have 2. Okay, so here we can say the first equation cannot be true for arbitrary motion, because average velocity, okay, at for any kind of motion we can say it is given by what final position minus initial position upon what time interval. So over here you can see that first we will understand the arbitrary motion. Arbitrary motion क्या होता है बच्चों? That is a random motion, random in all the way, in direction, in a magnitude, in a acceleration, in a velocity. Okay, suppose at any instant its acceleration is 2 meter per second, and it may have that next instant it have no acceleration. Okay, and it is also possible that at next instant its acceleration is also increases. Okay, it has no uniform acceleration, it may be a uniform acceleration it has. So arbitrary motion is random in all the way. Its velocities maybe increases, maybe decreases, maybe constant. Okay, one cannot predict it. Okay, one cannot predict it in a direction. Okay, one cannot get its expression. Okay, so such kind of motion cannot be expressed with the help of any expression. Okay, so that is called what? Arbitrary motion. So here you can see that in our first equation average velocity is given. It is the equation of average velocity for arbitrary motion. So is it true or not? So we can say this one is not true, because is the motion, this motion is arbitrary or not? Motion arbitrary hai ya nahi hai? But here we can say that the average velocity cannot be defined by this equation, whether the motion is arbitrary or uniform, which is expressed by any expression. But in both this case average velocity cannot be defined by such a equation. Okay, so the equation number 1 is not true here we can say. But here you can see that the second equation of average velocity is what? Final position at any time t2 minus initial position at time t1 upon time interval. Okay, so for any kind of arbitrary motion, whether it is in a straight line or in a plane or in a space, we can say average velocity is given by this equation. So equation number B is what? True. Okay, now let's observe the equation number C and D. In this two equation you can see that these two equations are what? Kinematics equation for uniformly accelerated motion. But here we have what? Arbitrary motion. So these equations are only we can use when there is what? Uniform acceleration. Acceleration uniform है तभी हम लोग ये equation use कर सकते हैं. But in arbitrary motion it is not possible that motion, or you can say that acceleration is always uniform. So here we can say these equations are not true for arbitrary motion, because there may be a non-uniform acceleration in a arbitrary motion. Arbitrary motion में non-uniform acceleration भी हो सकता है, तो हम लोग ये equation use नहीं कर सकते, क्योंकि हम लोग ये तभी use कर पाएंगे जब acceleration क्या होगा? Uniform होगा. And the last one is what? Average acceleration, and it's equal to what? Velocity at time t2 minus velocity at time t1 upon t2 minus t1. So here we can say yes, it is applicable for any kind of motion to find what? Average acceleration, whether the motion is arbitrary or uniform. The final, or you can say the average acceleration is given by what? Ratio of final change in velocity, which is what? Final velocity minus initial velocity to time interval. So this equation is true. So here we can say the relation A, C and D are not true for arbitrary motion. Okay.